I did the buttons. This is an ongoing thing, Manish, since you and I don't have Johnny here.
Yeah.
Once upon a time, way back when, this stream actually had a producer, and she was in the background, and she would always like
Mm,
perfectly execute the intro button situation, so that it was like just it was smooth, it was seamless, it was perfect. We miss her so much. And
yeah.
then unfortunately, she had to move on, and we had to figure out how to do it ourselves. And it's been more years now without her than with her, and we
Hmm.
still could not
Still,
get it right.
yeah. I
Um,
blame the software. I blame the software.
Actually, yes, they've changed this UI 3 times just in the last 12 months, and
Hmm.
I'm a cranky neckbeard about it. I am just like,
Yeah.
no, why are you touching my GUI? Stop. I didn't ask you to.
Yes. Yes. That's right.
Anyway, so ongoing joke is that we never get it right, but I think I got it right that time, and I'm very excited
You
about it.
nailed it.
I nailed
You
it.
nailed it.
Um, the replay will tell for sure, and I'm never going to go back and watch it. So as far as I know, I nailed it.
Yeah.
Um, Anyway, good morning, GitOpsians, or whatever time zone you're in. Manish, I know you are in London right now. Thank you for joining so late in your afternoon on your family vacation. Really appreciate that. Um, I will let you introduce yourself because I don't think I could do a better job of it. But go ahead and introduce yourself. Give us a little bit about Project Vail. That's what we're here to discuss today, and then we're going to get into, I think, just a nice conversation, right?
Yeah, I'm pumped. I think this is the audience that we love to kind of be in front of and talk about. So, uh, give you a quick background on Vail and what it is we do, and also myself, just for the audience to understand where I'm coming from. So, um, I'm an engineer. I've been building things my whole career, since when I was studying at UC Berkeley. I studied computer science there, and then immediately just started building software companies since graduating. And so I've always worked on things that have lots and lots of data and infrastructure, kind of like we were one of the first users of Hadoop. So if
Oh,
you're
whoa,
familiar with that,
that's a
deep poll,
throwback.
yeah, a deep
Whoa.
poll, yeah, and uh, we were one of the first customers of Cloudera back in the day. So lots and lots of affection for the operations infrastructure communities. The company that I co-founded was a data company called LiveRamp. I also have started companies that work on heavily regulated, privacy-centric things. Like in healthcare, I started a digital health company called PureWell. So got a lot of familiarity with the needs for building things with high trust, compliance, regulatory
Hmm.
sensitivities, and also all along the way over the course of my career, I've been working with AI, because whenever you have lots and lots of data, a natural thing that you work on alongside that is AI.
And
But previously,
I was gonna say, let's just pause
yeah,
and define that real quick, because I think a lot of,
yeah,
I would never accuse the viewers of this stream of this, because I know when I joke about being a neckbeard, we've got some serious neckbeards around this place as well. People who put me to shame in terms of like age and crankiness and experience. But let's just take a moment and define AI,
yeah,
because I think a lot of people, and potentially the casual viewer might just think, okay, AI, that's like, LLMs, but it's not.
mm-hmm,
And
no,
if you feel like really getting into it, we can also discuss the fact that the neural network frameworks used by modern LLMs dates back to like the 1950s. That's always a fun
yes,
topic of conversation to tell people
oh
about.
yeah,
But I won't necessarily rabbit hole us that deeply. But can you
yeah,
just define a little bit more about AI? Like I
yeah.
believe I know what you mean, but let's like for the audience.
Yeah. So for the audience's benefit, yes, AI has been around, or machine learning, as it was previously referred to, has been around for decades, right? It's been something that we've always chased in terms of how can we get machines to kind of function more like we do and do things and think about things the way that we do. Um, and previously, over the course of my career, working with AI meant like building and working with classical ML models. So building regression models to identify certain patterns, to classify things, to basically bucket them in different categories, to say this belongs here and this belongs there. Those are very common applications of classic ML. Then there was this kind of migration towards what we describe as generative AI, which is not just predicting things from the past, but using the past to generate the next in this new era, the next token, right? And so we're generating outputs that mimic or follow closely from previous outputs, and that's what started around the 2016 or 15, 16, and then really took off in the 2017 era where we had this huge leap with the transformer architecture. And now we're able to more reliably generate the next thing in a sequence, right? And that's what today everybody is using with LLMs, where LLMs are basically, in large part, transformer-based AI models that have within them a lot of these old style neural networks, but they're kind of composed in a certain way. But the way they're being applied is, how can we generate the next viable token, whether that token represents language or a pixel or um, a chemical sequence, right? There's a way to kind of use machine learning or AI to generate this output, and that's actually once you started to play with that, that was for me, and like I guess with like many people, playing with ChatGPT for the first time was like this big breakthrough moment about like, oh, like we've solved the Turing test. Like this is like just something completely new. And the way I saw it was, after having worked with classical machine learning and kind of previous versions of AI over the course of my career, once you really get a chance to play with generative models like ChatGPT and what's come since, you really have a sense that we're not going back from here. Like the world is like forever moved in this direction with this technology as a key moment where we're saying like, okay, this is what the world is going to be like from here on out. And for me, it was like, oh, I can see that this is going to one get rapidly adopted, but there's
Mm-hmm.
also going to be this rapid proliferation of similar models that are out there doing similar things, and there's going to be this kind of exponential growth rate in the not just the usage of these things, but the production of these things. Right, we're going to see more and more of these uh, frontier scale models that can do these ever more capable things. And for me, it was this question about, okay, as we hand over really important tasks, as we delegate to AI to do these tasks on our behalf, whether me as a user, a company, or a government or societies writ large, we're going to be delegating to these AI models to do things for us, right? Because that's what they've been designed to do. That's what they've been trained to do. But I think for us as users, organizations, as governments, as societies, we should still know which model at the end of the day is performing the tasks that we have asked. And is it the model that we think? Has it been trained correctly to do the work that we're asking it to do? Has it been switched to some other model that we didn't approve of? How do we actually know those things? Because we're mostly interacting with these AIs through APIs or agent harnesses now, or applications that wrap around a AI model that is actually running in some data center somewhere, right, in the world. So for
Unless you're
me,
like me and you've put Olama on a Mac
that too.
Studio that you're running in server mode, and then you just SSH into that, because I don't actually like the operating system super well, so I do it from my Linux
Yeah.
box over SSH, and then I interact with it that way. But that requires, buying the hardware, having the specialized
Yeah.
knowledge to set it up. There's some interesting stuff happening there with like Claude Code like wrappers and so forth for those interfaces, where it's
Hmm.
trying to catch those off, basically that ability to be disconnected is trying to catch up to what is being done with the API driven
Hmm.
tooling. And since I'm I know you're getting into this right now. It's what we're going for. Like, I'm very deeply
Hmm.
into, I want stable and repeatable and predictable as much as I can from
Yeah.
a non-deterministic system. So I don't want
Right.
the back end changing without my knowledge. I don't want the data set changing unless I've changed it. There's, so
Mhm.
unless you're doing that, unless you're me and you're just absolutely willing to spend all that time. And one of the reasons I spend all that time actually is a lot of the audience knows, and I think I mentioned this to you. I did write a book on AI for observability and operations, and I wanted to be like I wanted to be vendor neutral, right? I wanted to make
Mhm.
sure what we were presenting was so one of the reviews called it like pragmatic, and I was like,
Mhm.
thank you, that was the goal. Like that was what
Yeah.
I was like
Yeah.
striving for. We wanted to be pragmatic and vendor neutral. We didn't want to come out to endorse any one thing or the other, just kind of like talk about what is actually achievable.
Yeah.
Um, and funny thing, so for me, um, it wasn't the Chat GPT moment. It
Mhm.
was predictive chess engines.
Mm.
Those
Mhm.
chess engines that was like that little I don't even know how to describe it. It is a transformer architecture. It's a very
Mhm.
like a very like nice neural network implementation. I forget, it's like something fish, the exact one, right? Um Basically it's like these not even predictive, adaptive chess engines.
Yeah.
So as you
Yeah.
are playing against the computer starts adapting to you as a player and
Yes.
getting harder and matching your skill kind of like really accurately, really correctly. It doesn't have a chat interface or anything like that. The interface is the game. For
Right.
me, that was the, oh, this stuff's getting
Oh.
real cool.
Yeah.
Um,
Yeah.
there was also a very, very early, I don't remember if it was Stable Diffusion itself. Um, there's something along to like 2017-ish. It was like a very simple HTTP
Mhm.
HTML page or whatever, really. And you basically like almost MS Paint style, like
Yeah.
filled in a box, and then it would
Mhm.
render it into a landscape because it'd been trained on oil landscape paintings that were in the
Right.
public domain.
Yeah, that
Um,
was a
I,
Google model. I forget what it was called, but yes.
Yeah. So that one as well. And so when we're getting there, I was like, okay, this is starting to be interesting because
Mhm.
I'm somebody who I can't draw, but I can picture things in my head very vividly. I have the ability to like, I'm one of those people, like if you tell me to picture an apple, give it colors and variations and rotate it, I can do that. It's like the stem will have its
Yeah.
curvature and the shadows, and I can picture all of that very vividly, but I could never actually
Mhm.
like render that. So that was another moment for me where I was like, oh, this is starting to become the ability to like describe what's in my head that I could never take to paper or 3D
Right.
animation myself, not without years of skill, and start to become interesting. So then of course there's the whole like other ethical concerns and considerations about, okay, but then they trained it off of art that wasn't in the public domain, and you have
Yeah.
other
Yeah.
problems there, for sure. We're gonna gloss over them for this, but I would say those were my moments, like
Mhm.
the adaptive NPC, the like kind of like give you an impression of what I want, and you can kind of start turning it, and then I can
Mhm.
iterate over it from there. Those were my moments because I was working in IoT, so we're talking just tons and tons of data, distributed computing, and so forth. But we were not yet to we were building for the smallest possible hardware footprint.
Mhm.
So we weren't using AI or machine learning algorithms. We were using like other data algorithms to make
Yeah.
that immense amounts of data matter without
Yeah.
having to have high like all of the data historically kept.
Mhm. Yeah, and I think that that was kind of like part of the breakthrough that the team that came up with Transformers is that one, they realized, oh, we can use these GPUs that are just over here that are somewhat idle because at that time nobody was doing a lot of complex calculations, and so
Hmm.
they're like, oh, what if we just use the GPUs over here to perform these calculations, and now you can perform a lot more of them in parallel, and that was like, oh, there's a lot of room to run here. And then
Yeah,
once you start combining that with more and more memory, so you can really expand the parameters that are available to train over, that started to create, that was like kind of the beginnings of scaling laws, right? Where if you are able to provide more and more compute to produce ever larger and larger matrices of parameters, then you can really start to see where these things will go. And I think everyone is going to have their own moment. Like you had yours with maybe the canvas painting thing, and I had mine with the chat GPT thing. But everyone is going to come across their own moment, if they haven't already, about the use case or the utility that AI can really bring to them in their own personal world, right? Like for you, maybe it's you can now draw things that you can imagine in your head that you wouldn't have been able to do before, right? Or for some people, it's, oh, I can actually articulate an idea that I just couldn't write out myself or type in an email for someone else or send it in English when I'm not a native English speaker. So
Yeah.
I think these are the things that are just going to be in everybody's like history, where they figure out like, oh, this can do that. I'm sold. Get me
Yeah.
on the train, right?
Yeah.
But for me, I was thinking like that's going to happen, right?
Hmm.
And as that happens, as we kind of have those aha moments, we also start to slowly trust these systems ever more, right? Like, oh, maybe I could try this too. Oh, and this too. And then you get to this. I think somebody called it surrender, like this cognitive surrender moment where you just assume the AI is right and
Yeah.
it will just do it, and you don't have to think about it. That's why we see like all this stuff about like AI slop taking over. It's because people have kind of crossed this moment of cognitive surrender where they're just like, if the AI says so, I trust the AI. Like, who am I to question the AI? And I think that's a very dangerous moment.
Yeah.
Um, and I think it becomes especially dangerous if we don't have the ability to question which model is actually producing the work that we're relying on, right? Or we're handing to someone else, or we're building decisions around, right? You think about uh, all the areas where we're making critical decisions, where uh, we need to know, like, was it like what was the root of where this decision came from, right? Because quite literally, these are life and death decisions that are happening now. And
Yep.
if we don't have a grasp over which model it is, or who trained that model, where did this model come from, or if it even was the model that we thought that produced this so-called intelligence, I think that's what we are owed, I think as society, but we should know and have some agency over it, right? And I think that becomes a critical task, and that's really why I was motivated to start Vail, so that we can provide some of the tooling necessary to do this verification at the scale and the speed at which AI is really uh, entering the economy, right? And for me, it's not about using kind of old era methods of auditors that are kind of like in there with their pencils and stamps and like saying yes, you have a good model. It's really about building tools that can live alongside the AIs and can operate at the same speed and scale as them, and we can trust that those tools are providing some meaningful verification against the thing that we're relying on so heavily. And that's really the core essence of Vail as a company. Is like, can we build these tools? Can we make them available wherever people are accessing AI? And we can kind of go into what some of that tooling is, but really that's kind of what led us here today.
Yeah. And so that was actually how, I had heard of Project Vail before I met your friend, who was like, "Oh, I was at a security conference where I met him, and I said I love to go to conferences because this is where I find the suckers who are going to come and be my next podcast guest." And he's like, "Oh, I've got a sucker for you." So just so you know, that was what he said.
Yeah,
Just in case you didn't know that, now you do. Um,
I
and
love
he's
it.
like, "Have you ever heard of Project Vail?" And I was like, "Yes." And the reason I had heard about it was because I, in my book somewhere, I'll grab it actually. The mystery of the bookshelf. I've been doing this lately, and then things fall over because I have. It's all very precarious, but that's why it's so pretty.
Yeah.
so, so actually, in my book, at like towards the end, it's this one. People have
Hmm.
probably seen it if they watch the stream ever. Towards the end, I talk about exactly needing to have trust in the AI system and how do you build that trust. And at the time I
Mhm.
was writing this book, because I was writing this, it published in like March, but I was writing it last summer. I was writing it a year ago. At the
Mm.
time I was writing this, there wasn't a whole lot out there. And I do believe Vail was there at that time, but probably due to newness, it just didn't show up in my searches. And it
Mhm.
wasn't until after this had published that I saw Project Vail. But I was already at that point um, looking into how do you verify, it's kind of the assumption is you have a model, like a foundational model, but then you've been fine tuning it and training it and so forth the whole
Mhm.
time. How do you verify your after state is as good as your before state? And so that was where I got into some of the natural language process scoring using tools like deep eval, so you can have an SLM grade the LLM.
Mhm.
And you can have like very, very, very small ones that even just run on CPU. Actually, I had to change my live demo one time for that because I didn't have enough GPU on my work
Mm.
machine, turned out.
Mhm.
Um, but also like Rouge and BERT scoring, and the problems with those being very objective scoring systems on something that would be subjective, right? Which is like
Mhm.
I told, like the example I gave was like I told the machine to like optimize for tokens in its output.
Mhm.
And so the response it came up with, which was optimized for tokens, was very satisfactory. It scored terribly
Mhm.
on I think on the BERT score. It scored slightly less terribly on the Rouge score. But it's like, okay, but given all of the parameters of what I told it to do and how to perform,
Mhm.
I'm subjectively very happy with this response. So like thing that didn't really try make it into the book, but exactly was I was sitting there going, there needs to be another model. There needs to be another way to score this where I can have that
Yeah.
mixture of that objective, this is X good, with my subjective of it meets my business need.
Yeah. Yeah.
And that was something that I've been continuing to look into and so forth. And while Veil, I wouldn't like reduce it to that because you do a bunch of other interesting things with like identities and so other stuff. Um,
Mhm.
I that was a little bit how I came across this. As I was like, I want it to
Yeah.
be measurable. I want it to be auditable. What something has to like. I had like a moment where I was at a different CNCF event, and somebody had produced their like platform that had a bunch of the features in it that I had expressed would like should exist in my book, and I was like, yes,
Yeah.
which means I need to go look back. What has come up, or what can I find now that I
Mhm.
didn't find 3 months ago? That was when I found Vail. So I
Yeah.
coincidentally met somebody who knew you. You're only ever so
That's
many
awesome.
degrees of separation in the San Francisco tech community. But he'd asked me if I'd heard of it, and I was able to definitively
Ah,
say yes, I know that.
that's awesome. Yeah. Um, yeah, and that's kind of why I'm here today. I think more people should know not just about Veil, but about this kind of new paradigm that we're entering into, right? And the way I kind of try to describe it to people is, over the course of like computing, we've really looked at maybe a handful of metrics to understand if a system is functioning, right? So
Hmm.
there's the basics of like, is it up, right? Like green lights, is it running? How, and then we have like, how many nines of uptime that we try to like handle for, right? And then the second is latency, like how fast is it, right? Is it actually responding at the frequency that I need, right? How quickly am I able to get data out of the system? uh, and then the third is throughput, and throughput and latency are very correlated, but
Yeah.
like, is it able to process the amount of data that I need, right? How much data can I get in and out of this system, in addition to speed and in addition to just basic uptime? And if those were all green, then we were like, system is working, nothing to see here, like let's move on. And everything kind of just like carried on. Um, and with AI, there's this whole new thing that we don't have metrics for, that we should be paying attention to, which is, and largely we describe it as behavior, right? Like these AIs have their own behavior. They have their own behavior patterns that change in the changing environments that they're in. I mean, you mentioned how you want to run these models locally because you can tightly control and constrain the amount of change in the environment so that you can get much more deterministic behavior from this model that's running on your local machine, right? Um, and that's great if you can do that, where you can control all the everything about the environment. However, that's not the real world, right?
No, it doesn't
And
work on the
even in
enterprise. Doesn't remote like I work at an enterprise company, right?
yeah,
Doesn't remotely work in the enterprise.
no,
You just the cost
it's
of that
things
is
are changing
yeah,
all the time. And not to say that there's like changes that happen for malicious reasons. There's change that happens for good reasons, right? But what we've noticed, and some of our tools have shown, is that when the environment changes, it changes the behavior that you get from these models.
yeah.
And some of those behavior changes could be benign, meaning like if you're running a chat agent or a chat AI, and instead of saying hello, it says hi, right? Like that's a okay, that's fine by me. I don't really mind that it said hello or said hi instead. Um, but when you're starting to go deeper, or you're starting to see much wider breaks in behaviors that may be more subtle, right? Like if you're now, instead of running a chat um, AI where each turn is just a text back and forth, but you're now running an agent that is running a workload that has many steps to it, and at step 5, it the behavior changed where the model chose a different uh, you know result, right? And
Hmm.
it could be something like it chose to use this tool instead of this other one, or it chose to use this argument within this tool instead of this argument in this tool. And at step 5 it might be fine, but or it may not be fine, but you won't notice until you're at like step 70, and now you're like, oh, this whole chain of events led this model down this like very wrong path, that now, if it's possible to, it needs to rewind or unwind itself to get back to that first step that it took wrong, or it's not recoverable. And thankfully we have sandboxes now, but that's where we're
Yeah.
seeing a lot of you know unintentional consequences of these uh, behavior changes just as a result of the environment within which these models are running. So and when you really break down the environment that hosts these models, there's like so many different moving parts because these are incredibly complicated systems.
Yeah.
So getting everything right and lined up at the same time so that these models can stay coherent, and coherent long enough and consistent enough such that you can run repeated high value workloads with them. That's what we all want, but we're definitely not there today. And our opinion is that we should just at least be measuring how much volatility is there in these behavior patterns, and we should have a new way to measure these things besides just looking at basic uptime and latency.
Yeah, it's interesting because so one of the things that I've seen, I've been working on a couple projects. I've been working on I'm a major project for work that I was heavily interfacing with an AI coding assistant for, and then I have this kind of like previous episode was like doing a capture the flag game. So I have this like AI assisted capture the flag game with like an actual AI agent that runs in the capture the flag game and does things and has
Mm,
actions and so forth. And then old school like agent, not an AI agent, but just like when we say agent, this thing that
yeah.
like has agency in the system to do some actions based off of like it's just automation, like a little basically a
Hmm.
Linux daemon.
Yeah.
And so but I've been working with both of these things. One of the things that I've noticed, and I'm using two different models for each of these, like
Hmm.
is both of these models like from different vendors, because I have my work vendor and
Hmm.
the personal are different. Um, they are both recently. I've never seen this happen in the year plus I've been interface working with these tools. Dependency version problems and mismatches are
Hmm.
all like I've noticed them all of the sudden. And it's like, oh, okay, I actually had to write an instruction file like stop adding a Golang
Yeah.
version to .bingo. Don't do that.
Right.
Knock it off.
Right.
And also don't do one that's 3 versions of Go behind. I didn't put that in the instructions, but I thought it loudly
Yeah.
at the AI agent. Um that's a problem. But then I was
Hmm.
working on my personal project, and I was like, oh, I have to troubleshoot this issue, and I'm like, because I'm paying attention to it, I'm not, I sit down and I make sure I focus on it. I do not let the eye glazing over happen. Takes 5 times as long to do anything, but then I caught it. Oh, I ran into a problem. Let me troubleshoot. I hit cancel. I said, no, you have a dependency version mismatch. Go look over here,
Hmm.
get the correct version, work from there. And it was like, oh, you're right, and immediately fixed. But who knows how long and how much money it would have cost me if I just let that
Yeah,
go. And
that's right.
I was using a vendor for that because I wanted it to actually write out and like write commits and so forth. And my Olama thing is not quite. I'm working on it. I'm going to get it there.
Yeah,
Um,
yeah.
I've got an open
Well, I mean,
source
that's
tool involved.
the dream is that we can get the, Mythos, Fable, GPT-5 6 class models running on our machines, like locally. They're not there
They're not
today.
there.
Maybe eventually they will, but like right now, if we want the actual like really frontier of these AI models, like there's no other way to get them besides through API.
Yeah.
We're getting closer with open source models, which is another area that we're very excited about. Um, and with like GLM 5.2, like it's pretty much on par now with Opus 4.8. So I think we're getting one step closer, right? One step
Yeah.
closer.
Yeah, it's still, I don't know how far we are. I mean, the thing is I think we have to change our mental paradigm as well. We can't expect deterministic behavior from non-deterministic tools. All we can
Yes.
do is put up governance and guardrails and so forth. And even still, I've seen it blow right through those things.
Hmm.
So they have to
Yeah.
exist on the systems level.
Hmm. That's right. That's right. And that's kind of like our whole ethos, right? Like there's uh, tools that need to be built to kind of understand the like the probabilistic outcomes that are happening, right? And are they like 99% correct? Are they uh 80% correct? And like you have to find what the trade-off is and what is the reason that it's at 80% and not 90%. And we've seen things where there's real things that are messed up in the way the model was deployed, right? Like if you talk about a model that just comes out, but it's not fully supported by an inference engine like VLM or SGLang, then you're not going to get the best of the model. It might be
Hmm.
like half of its capability just based on that misconfiguration of the system that's hosting the model and the model itself. And it's hard to know, is it the model that's broken? Like maybe the model is just not good enough, or maybe it's just not supported properly, and
Yeah.
this is an ongoing debate right now in the AI community. Like it's hard to know where the fault is, if there is any. And sometimes it takes like a couple weeks for a new model to kind of get baked in to the commonly used infrastructure, but sometimes it takes longer, or sometimes there's other priorities, right? And actually we see this happening right now. So like forget about the new models that come out. When new models come out, it affects the older models, right? So we
Hmm.
see this in our data. So you posted this link to our stability arena. There's actually a really interesting um, observation that we've picked up in our data, which is anytime Anthropic releases a new Opus model, it has impacts on the behavioral stability of the previous version of the Opus model. So when we're monitoring behavioral stability on a like hourly basis with each of these endpoints. If you go to the arena, you can see, and we're checking to see like, is this model behaving in a relatively close manner to a baseline set of behavior that we captured. And time over time, if the model breaks its behavior, we consider it like the behavior has shifted enough where it's no longer closely related to its baseline behavior. Something has changed behind the scenes that has caused this model endpoint to behave differently. And so what we observed with when Opus 4.6, when Opus 4.7 came out, there was an immediate baseline break with Opus 4.6. And then the same thing happened when Opus 4.8 came out. 4.7 had a big baseline break. And then when Mythos or Fable was released and then taken offline, the day that Fable came back online, Opus 4.8 had a big break in baseline behavior, or from its baseline behavior. And now, why is that happening? Well, it's actually quite obvious when we think about it. Anthropic does not have an infinite amount of compute to allocate to all these models. So when a new model comes out, it's typically going to be bigger. It's going to need more resources. So they're going to take from the previous models and give it to the new model. So now all of a sudden you have your Opus 4.6 model that your enterprise has like approved and built prompts and guardrails and everything against. Now, all of a sudden, that model hosted in some data center has half the amount of compute and half the amount of RAM available for its KV cache. It's not going to behave the same. It doesn't have the same capacity to behave the same.
So,
but you're not really able to see that.
Yeah. So actually, funny thing, and I admit to this in my book. So in chapter 2 of my book, it's like an introduction to LLM-based AI and like what can and will go wrong. At the end of the book, I confess I created the failures through resource starvation.
Mm-hmm.
I actively starved it to make sure it would fail.
Interesting. Yeah.
And so it you're welcome. I'm a genius.
You've been ahead of the game on a lot of these things.
I did so much research on this, on this. But yeah, no, I actually created the failures through resource starvation, and I caution on that topic. And again, a lot of the tilt to the book is assuming that it's not assuming that you're using a vendor, because we didn't, again, neutrality, being neutral was really, really important to us, especially because one of my co-authors, he works for a startup. He used to work at Red Hat. The other one, he works at Dynatrace. And so here we are, we're people who work at these big enterprise companies. They're not paying us to write these books. This is something that we're doing in our, evenings. So we wanted to make sure it was clear that this was us, not our employers. But yeah, and this is I'm a reliability engineer. And before I was a reliability engineer, I was a quality engineer for over a decade. It's not hard for me to figure out how to break something.
Yeah.
I'm pretty good at it.
And that's what's like necessary, right? We have to figure out how to find the weak points in this system that we're saying is going to rewrite all of software in use today, which is crazy to think about, but it's actually happening, right? So I think it's really important that we try to push and not just like blindly trust that everything is okay and these guys are all paying close attention to this stuff, because they're not, right? Like even it's in favor now these days to pick on Anthropic just because like things that they've done to run for us.
I can't pick on Anthropic, but you're my guest. You can say what you want.
Yeah, I have friends there, so I'll be somewhat nice to them. But these are all problems that they've acknowledged publicly themselves. So 6 months ago, or I think it was 9 months ago, they actually shipped the wrong set of weights to a different data center, and so it took them about 3 weeks to recognize that it was the wrong set of weights and things were just broken, and the code that was being generated was just like flawed, and they didn't notice, or it took a while to figure out what was the root cause of that. But these things are happening all the time, right? Sometimes we think we're more clever than we are, right? And for another example, with some inference provider, we were noticing that their deployment of a very large open source model was, on traditional metrics, it was really, really fast, like 2 times, 3 times faster than Google hosting that same model, which is kind of crazy to me, right? Mm-hmm. Some hyperscaler versus some neocloud. And then the throughput was also fine. The error rates were low, but we were seeing this constant fluctuation in its stability. And when we dug into it, it's like, oh, they're doing this kind of special thing around speculative decoding, where they put a smaller draft model in front of the big model, and the draft model is meant to kind of predict what the bigger model will output, and then the bigger model can just kind of check and verify and then send it out. But there was definitely something wrong with it, because the behavior time over
That
time, even though we're asking it the same things, the behavior was like way shifting all over the
that
place. And
that's
so,
interesting because I would have done that in the reverse. Have the SLM sanity check the LLM, because unless everything that you're doing is so repeatable, like you are always doing math and you're never
mhm,
going to ask it about history, right?
yeah,
The SLMs are really good on a, like, that's the purpose. They don't have a lot of parameters, like very narrow
yeah,
set of data. So I would have done that in the reverse, but I absolutely would have done that because it's genius. But I
yeah,
would have done it the
yeah,
reverse way. I would have had it go to the LLM first and then the validation of correctness by the SLM on the
yeah,
way back out.
yeah. For them, the benefit, like, so for the in that situation that I was describing, the neo cloud, their primary optimization uh, is uptime and time to first token, which is
Yep.
basically that latency and throughput metric, right? And so they're trying to do whatever they can to stay at the top of whatever leaderboard on how fast is it, how much is it up, right? And so um, we think that that's maybe a false optimization, where you're maybe not paying close attention to the tokens that are actually coming out, because
Hmm.
you're solely focused on, well, it's fast, it's the fastest that's out there, so we're doing a good job. And those are the things that we want to call out, because it matters, even if it's like
Yeah.
maybe a little bit slower, but if it's the right set of tokens, then you're you're going to be better off, right? So
Yeah.
those are the kind of ways that we're trying to surface for people, that these things behave very differently time over time, and we can't just rely on um, somebody running an eval against these models to say, oh, it's an 80% on math and coding, better than any other model that's out there, and that's what we then use to do all of our coding in our company, right?
Yeah.
But it and it may be true that when you evaluated it, when that eval was run, that it was achieving this very high benchmark score. But when that model is deployed, and where you're accessing it from, if that deployment is botched, you're not getting that 80% capable model, you're getting something else.
Yeah. You have to
There's
do
regressions that happen.
continuous evaluation.
Yes, that's right. And so we've been kind of like, maybe we're the only ones on this hill, just like yelling into the void, that we need to run continuous monitoring against these systems to know
I
how they change time over time.
I wrote it in my book. It's not just you, it's me too. I've
Oh,
submitted to
awesome.
KubeCons on this topic. Actually, I didn't get accepted, but that's fine. Well, I didn't get accepted to KubeCon Japan. I've submitted it to
Like,
others as well.
you're one of us. You're
I
you're
want to,
on
yeah,
the train.
I'm
Just
on this with
keep
you.
keep going.
The talk white paper is called "Your AI Needs CI." Like,
Yeah,
that's the
yeah,
paper, and I've got the code and the pipelines to prove it.
that's great.
But that's fine. It's kind of, there's nothing stopping me from talking about it on this stream, obviously. That's part of why you're here. But it's fun to go to KubeCons and
Hmm.
present these topics too.
Oh, for sure. Yeah, and I think there might be some waking up that's happening to this. Maybe it's not reached the mainstream just yet, but as more and more people reach those aha moments with AI, and they start to use it in productive capacities within their companies, or they're really trying to build resilient workloads against these AI systems, they're inevitably going to trip over these things, and that's where we want to be there ready to say, like, hey, yes, I'm sorry you got screwed in this situation, but here's how you can kind of build more resiliency into your whole system, because you're not going to just rip out the AI, you're just going to try it again.
That's one of the things that I keep telling people when they're like, "What do you need to?" Because I get asked this a lot, like, "What do you need to implement an AI solution well for like ops?" And I'm like, "What's your automation strategy?
Hmm.
What's your blueprint for automation? Because if you just drop it in to be a silver bullet and you don't have an overarching automation strategy, an overarching automation story,
Hmm.
it's not going to go well for you,
Yeah.
right? It's not going to go well for you. You need a thing. And so a lot of a lot of tech leaders rightly recognize that this is a transformative piece of technology. But it is, I think the problem is the silver bullet, like hopes. Um,
Mm-hmm.
if you don't have a strategy of like, what is my automation strategy? And we say, what does an automation strategy even mean, right? It's what are what are you seeking to achieve through automation? Like what would make your humans more efficient? And how do you measure success of that? And how do you continue to measure success of that? Because I have, like, there's places where dumb automation just suits. It's the right
Mm-hmm.
thing. It is the correct tool for the job. Just do some dumb automation, right? A Kubernetes operator is sometimes just the thing that you need. And there's no, like,
Mm-hmm.
you wouldn't throw LLM at that problem that a Kubernetes operator can solve, right? So what is your automation strategy? And is LLM the right tool within that strategy? And then how do you make sure
Mm-hmm.
your strategy continues to work? How do you, this is the quality engineer background to reliability engineer today, is just like, okay, but how do you keep measuring that it's good? You measured that it was
Mm-hmm.
good to go out the door. Obviously you had to do all of that. Ideally you did
Yeah.
all that. Please do that, folks. Um, you measured that it was good enough to go out the door, but then how did you make sure it was still good after the fact, right? How did you make
That's right.
sure? Because one of the things that I see a lot in systems, I will say the last probably 2 years, this has been less true. No, I take that back. This is still true. Um, software we build today is not built with the idea that it will run continuously for years on end. When my father-in-law was writing COBOL software on mainframes, he knew what he was writing needed to run continuously for years on end and would work. And some of
Mm-hmm.
the COBOL software that he wrote is probably still in use from all
Yeah,
those
still
years
running.
later. In
Oh
fact,
yeah.
he was one of those engineers got called out of retirement to go and update the COBOL like stuff around the place. And did very well for himself on that for quite a while. But so the belief then was, oh, this, well, they thought it would eventually be replaced, but they knew
Mm-hmm.
until then it would run continuously. A
Mm-hmm.
lot of the software we build today expects to be upgraded very regularly and restart very regularly. And when you don't do that, some of the most interesting production breakages I have seen have been from systems that were not upgraded, so therefore did not restart. And in that
Mm-hmm.
long tail of behavior, that is when
Mm-hmm.
things started to get really weird. Um,
Mm-hmm.
best one I ever saw, Ghosts in the Machine. It was a very, very, very old OpenShift 3 implementation, and the networking layer believed pods that no longer existed were still there and kept trying to send things
Mm.
there, and basically caused TCP socket exhaustion because
Mm-hmm.
enough of the remnants of it was there to
Wow.
to try to create the connections that just were always like just stayed open until eventually they failed and terminated. And it's like that was
Mm-hmm.
the first time I saw TCP socket exhaustion in the cloud. I have since seen it 5 times. It's a joke because my best party trick is I can diagnose TCP socket exhaustion without looking at a log line, which I did a few weeks ago, a couple months ago, and really irritated my coworkers because they were like, "Where were you 6 hours ago?" And I was like, "Sleeping. Sorry, I wasn't awake yet." Um, but long running systems. And so we do see this with AI context windows, though, which is interesting because what is the like long running
Mm-hmm.
shrinks, right? That is shrinking now. What long running means, what is long running? But
Mm-hmm.
it's the same thing. Like software is not really optimized for long running. We have a problem here in our AI systems and their context windows, in our general software systems. This is one of the most interesting problems that we have, and I don't know how to solve that, but I see it a lot.
Yeah. Oh yeah. This is it's an ongoing issue in the research community, right? Like how to allow these models to run for, hours, weeks, days, months at a time, right? Because the idea is that they can achieve more and more like um, productive things if they were given more time, but it also runs against this risk that their context windows get flooded, or there's now the term of context rot,
Oh
where
yeah.
and this actually goes back to what I was describing earlier about, agent workloads, where if they achieve something wrong at an early step, then it basically taints or pollutes the data that then is being processed at later steps, right? And now when it has to backtrack, it maybe doesn't backtrack all the way, and it doesn't actually catch the root error that occurred, but now it's writing on top of itself more and more error prone like data. So now the context window has been polluted to the point where it doesn't know where to like start from, and it might just be looping on itself on this like bad reasoning data, and it's convincing itself to keep doing the wrong thing, and then you have to like intervene to kind of reset the context window to blank slate, and now all
I
that work is likely to be lost. It's
I actually,
definitely
so
likely to be like needs review.
yeah, so I when I'm working on something complex with an AI coding assistant, I'm not, I have mixed feelings on admitting this. What I have it do is we write a very detailed execution plan for what we're going to do.
Hmm.
I
Hmm.
say we like it's a person, but whatever. Like what I'm going to do with this AI coding assistant. And then after each step is successful, I
Hmm.
clear the context window, feed the plan document to the clean context window, have it review the previous step, and make sure it was
Yeah.
done correctly.
Yeah.
And then and this works more successfully, I have found, than having a different AI model like review the previous model's work. That still
Yeah.
does do some good, but it doesn't really add
Yeah.
a unique or intrinsic value. And I still need to be paying attention to the review because the review can have problems as well.
That's
So
right.
so I do this thing where I break the project down into like little individual steps, like well-defined tasks. And at the end of each task, clear the context, have it review without the context, right?
Hmm.
Here's the plan
Hmm.
we were following, here's the code that was written, how did we do? And like I also am like reviewing all the changes it's making as it's coming through.
Yeah.
um Otherwise it does things like try to introduce vendoring where you don't want vendoring, or go versions to .bingo where you really don't want them, or other weird things I've seen it want to
Right.
do, because it's just like a statistical probability machine of like, oh, this is a best practice, this must be what we want. No, we don't want that. We're building a capture the flag game. We need a security hole on purpose. Stop it,
Right.
right? Um, these are the arguments I have with it. But yeah, so I clear the context window, and then I go
Yeah.
for it through the next well-defined task, and then I do it again. And so I know
Yeah.
if I get to compaction, I let it finish its compacting process, and then I clear the
Hmm.
context because I realize I've let it run too long.
Yeah.
And I just feed it
Yeah.
more of what we're doing, where we are, go back and check and make sure that we're where I expect us to be, things are how I expect it to be, and then if signals are green, let's move forward. This gets me better results than if I just, and I've played with both ways. If I just let it
Yeah.
go and keep compacting and so forth, it'll be like, great, we did the thing. And I'm like, really, we followed the exact plan. Yeah, we followed the exact plan. I'm like, really, we have this exact outcome. Oh, no, we don't have that exact outcome.
Yeah.
Yeah,
That's right.
shocker. I mean, at this point, I knew that because I was testing,
Yeah. You're
but
paying attention. Yeah.
I was paying attention.
Yeah.
I was looking to see what it would do. But I have found regularly clearing my context window gets me better results.
Yeah. And that one, that's a lot of mental burden. Like you're kind of having to be locked in
Yeah,
a synchronous setup. But now there's these things like slash goal and auto research and other things where the intention is to actually set it and forget it and like move on. Like you're letting it cook for however long it needs to achieve some goal. And so you're not actually there to monitor and manage the context window yourself. And so we'll see. Like maybe the models are getting better at detecting these like missteps and then backtracking properly without intervention. But there's lots of people have different approaches to this. That we'll see what the common practice is, or if
yeah,
we can build tooling to lessen that mental burden that it takes.
yeah. I was using Copilot. Um, and first of all, one of its messages sometimes when it's thinking is summoning Clippy, which brings me so much joy. Especially because like I was on like the computer labs in the 90s at my elementary school where when Clippy was like suddenly became a thing and we all were so excited about clicking him so that he would do all his little animations.
Yeah.
I don't remember ever using him for anything important. Not the point. So that made me really happy because it's just the 90s nostalgia for me. Early 2000s, late 90s, early 2000s nostalgia for me. Um,
Hmm.
and then one other thing it did is I was using one of the GPT models and
Hmm.
it spun up a sub agent and it said consulting with, and I think it was one of the Claude's models actually. I
Hmm.
have Enterprise Copilot, so mine does other things. Don't base your Copilot expectations off of mine because again, I have Enterprise Copilot. I also have Enterprise Claude, and I found my husband his experience with Claude versus my experience with Claude vastly different. We see very different
Right.
behaviors between the enterprise subscription and the non-enterprise subscription.
Hmm.
So that's also something to note. On the same models, same exact models, right? And so,
Hmm.
or theoretically the same exact models, but they're not. And but that was something I saw that I'd never seen it do that before. But I'd asked it something for something so complex that even with a
Hmm.
fairly clean context window, it went and consulted a different model. This was not
Hmm.
something it asked me permission to do. This is not
Yeah.
something I've told it to do. This is not something in my preferences or rules files or anything like that. It is a behavior built into Copilot itself. And it was
Hmm.
very, very interesting to see that happen and the result of it because it
Yeah.
actually called it, it said rubber ducking.
Hmm.
I
Yeah.
was like, hmm.
Yeah. And I think there's a lot of these kind of preferences that are like, there may be preferences of the makers of the model, but not necessarily the preferences of the user that you kind of just have to live with because I don't know,
Yeah.
it's not so easy to turn them off. And the models have their own behaviors, right? Like you just experienced that the Copilot is um, going external for some, you know, check, to say, ask this other model what it thinks. And yeah, it's cute that it's saying like, "Oh, I'm rubber ducking," which is very common in the developer experience. But you didn't choose, like, you didn't say to do that or not do that, or which model is it choosing
Mm-hmm.
to rubber duck with. I think that's where a lot of this is going, where there's just like so many different configurations that are set on your behalf without telling you, and then you just have to live with, and then you just kind of they come up as you're using them and you're like, wait, what, why am I now using Sonnet for this thing? I was supposed to be talking with Opus, and now my tasks have been decided for me. Oh, I think we just got cut off.
No, I didn't.
What
I
was
just got rid of the
okay.
screen share because we weren't discussing
Oh,
it anymore. And we're
that's
coming
true.
towards the end
That's
of
true.
the top end of the hour. So
Yeah. Well, yeah, what I was saying is that, the sub-agent selection is, maybe it's in the harness, you can set a configuration, or maybe there's some, managed service where it says like, "Oh, well, we have determined based on our kind of analysis of your prompt that you and this prompt should be fine with Sonnet or
mhm.
Haiku or whatever," right? Like, and that's, I feel not so good about that. Like, I want to decide,
Yeah.
right? If I'm the user, I should have some power over this. And more and more, we're losing more and more of those decisions.
Yeah. No, and that's where I really like what you all are doing at Vail. We are coming to the top of the hour, so I want to make sure you got the opportunity to say everything you wanted to say because we really just sat here and were nerds about the whole situation for an hour, which is about correct for this live stream.
Yeah.
But yeah, you took your time out of your day, out of your evening with your family. So any closing thoughts, things you wanted to make sure that you got an opportunity to talk about?
No, I mean, I think we covered a lot of what we care about, which is how can we build the tooling necessary to trust and verify these systems that we're becoming more and more reliant on. We do a lot of different things under the hood. So uh, we showed the stability arena where we're monitoring these AI systems for behavior changes and kind of picking up different signals and what's changing underneath. We're extending a lot of that behavior to continuously monitor for other things like, tool calling accuracy and behavior consistency and kind of things like that. We've also done a lot of work on understanding the origin of where models come from, especially open source ones, where we can see based on what how a model behaves, was it a derivative of some other model, right? So if you download a model from Hugging Face, for example, and it says it's like trained from scratch and all of that, but when you what we do when we generate our fingerprint for the model, we can see that, oh, actually this model is very closely related to Quen, or it's very closely related to Kimmy. And so you can start to sort out, is this a model that I trust? Is it one that I want to use? And do I believe everything that's in the model card, for example, that the model maker has said? So we do a lot of work like that. So I think for the audience, yeah, we're trying to build this stuff as fast as we can because AI is moving so incredibly fast. So if there's people that are interested in this work, we would love to talk to them. We're all just nerds.
It's me. I'm interested.
Inside. Yeah. So, we want to work with people that just care about this stuff, are nerds about it, and just want to dive in and figure out how to build the right tools that help us make this work a little bit better.
And so I know you have a PyPy module, but I guess you don't have, which no judgment, but you don't have an open source repo or anything yet, or at this time, possibly never. That's fair.
At this time, so the challenge is, like, obviously we're very committed and we believe deeply in open source. Some of the tooling that we're doing has implications for like defense and security and things like that. So open sourcing it might actually be counter to our objectives in that way, because if we open source our methods for fingerprinting models, then they can be reverse engineered, or they can be kind of manipulated by the thing that we're trying to fingerprint. And so it becomes harder for us to kind of just openly release the work out there. But we try to publish our research so you can see what we're working on. So we have a few publications now that are accessible. So where we can, we try to share the knowledge that we're kind of working on.
Yeah, well, if you ever decide to do something open source with the like model stability aspect of it, definitely let me know, because I care so deeply about this. It is, but there are things there, right? There's deep eval and other tools that can be used to build bespoke model stability. For folks who are interested, again, that was a thing I put in my book. People can go check out the code repository for the book is actually open source, so you don't even have to read the book. Just go check that out. But yeah, so let me know. I care so much.
Yeah, I would love it, and we will definitely reach out.
All right. Well, thank you so much for your time and the conversation and the discussion. I will go ahead and link your the PyPy here in the no, this is a Mac loaner laptop, because my other one, the RAM corrupted on my Linux machine, and I have to get it fixed.
Oh,
I was upset. So I have a loaner laptop right now, and it is a Mac, and it's fine.
Yeah,
it's fine. Everything's fine. It works real good. The RAM is not corrupted, so there you have it. Anyway, but yeah, that's gave me some problems with the copy paste. It's once or twice a day I forget what machine I'm using, and I don't copy paste correctly, but I got it. It's good. Okay, well, thank you so much for your time. For our viewers, we will be back here in 2 weeks. I don't know what the stream is going to be yet. I think I want to do a capture the flag game again, because I think I got the AI LLM defense actually working ish. Nice. So I'll find a player for my capture the flag game, and we'll be back here hopefully in 2 weeks with that. Otherwise, keep an eye out on LinkedIn for what we will actually be doing, because even I don't know. Oh, wait. Shoot. We may be having Christian Hernandez back to talk about declarative networking from Cilium. that was also the other thing. I have a schedule maybe this year for this stream.
Nice.
It'll be one of those two topics. Either Christian Hernandez will be joining us back again to talk about declarative networking with Cilium, or we'll be playing Capture the Flag again with a new victim, player. Tune in.